Okay, so real quick, I want to ask you guys, how hard is this quiz? Is it kind of challenging? A little bit? Yeah. Yeah, so basically I made it a little bit challenging just to kind of challenge you guys, get you guys good on scientific hypothesis, scientific theory, but we're going to do this together. So I want everyone to look at this page right over here. Look at the very front page. We should have your name at the top, and let's read through this real quick. Okay, the first question says, identify each statement as a scientific hypothesis, a scientific theory, or not scientifically testable. Okay, what's a hypothesis? Whenever I say hypothesis, what are some of the things that come to mind? The first things that come to mind. What's a hypothesis? A testable statement. What else? Tells you what's going to happen. What else? If and then. Very, very good. I said if and then in it. Okay, real quick. What I want you guys to know is that a scientific hypothesis is going to be basically made up of three things. It could have if and then, but it necessarily doesn't have to have if and then in it. Also, scientific hypothesis basically is a statement that is testable. And I heard one of you guys say that too, so very good. It's a testable statement. So, real quick. Number one says, if the car is heavier, then it will take longer to stop once brakes are applied. Number one, is that a scientific hypothesis? Why? Okay, cool, very good. Because that has if and then in it, and it's testable. So, real quick, I want you guys to take a look at the board. Here it says, if I increase my bench by 20 pounds, then my chest will get bigger. There's an if and then statement. Now let's just say, I switch this up with suppose. Suppose I increase my bench by 20 pounds, maybe, or probably my chest will get bigger. Is this still a hypothesis? Is it still a hypothesis? Why? What makes it a hypothesis still? Because you can still test it. I have access to weights. That means that I can go get a bench and start working at it and see if it actually follows through, if my chest actually gets bigger. So it is still testable. So I want you guys to keep that in mind. Okay, number two says, the universe began as a small space of massive density and exploded out from there. Is that a hypothesis, theory, or not scientifically testable? Why is that? Very good. You can't technically take the universe. You can't take the universe and blow it up and explode it from the beginning. It already exists. So it is true that it's not testable. Also, what else is it? It's a theory. Very good. Okay, so if it's not testable, what makes a theory a theory? What makes a theory a theory? Kind of close. It's kind of a guess. It's kind of a way of basically what makes something a theory is after years and years of research, data collection, and just constant trying to come up with an explanation for something. That's what makes it a theory. You can pretty much make a theory out of anything. But in order for that theory to become a sound theory, there needs to be hard data, hard evidence, and just lots of research in it. And theories help explain things that we can't normally test. We weren't there necessarily to actually observe it happening. For example, the evolution of man. We weren't there at the beginning whenever man evolved from a single-celled organism to multiple organisms. We weren't there for that to happen. So we have to use that theory of evolution to help explain that. Now, can you prove a theory? Can you prove a theory? Can you prove a theory? Yes and no. You can't necessarily prove a theory, which is why it becomes a theory. If you could actually prove it, it'd make it a fact. So since we can't prove it, it's still a theory. But it's a theory because after years and years of research and data collection, that it kind of comes to that point where we just call it a theory because it helps explain something we can't necessarily prove or take as fact. Okay, real quick. Number three says, this sample of pond scum will contain euglena. Is that a hypothesis, a theory, or not scientifically testable? Okay, why is it a hypothesis? Because you can test for it. You can actually go over to a dirty pond, pick up some water, stick it in the laboratory, and go ahead and test it. What makes it not a theory? Because it's provable. Very good. You can actually grab some dirty water, you can actually test it and make sure that it's you can actually prove it to have that bacteria or prove it to not have that bacteria. You can actually prove it. Okay, number 4 says, cockroaches are afraid of light. Cockroaches are afraid of light. Is that a theory? Is that a scientific hypothesis? Or is that not testable? Okay, so real quick, why don't you guys pull out your whiteboards? I want to see where your guys' heads are at. So, on your whiteboards, you guys are going to tell me if you believe it's a scientific hypothesis with the H, you guys are going to tell me if you think it's a theory with the T, and then you guys are going to tell me an N for not scientifically testable. So, go ahead and write down your letter of choosing, but don't show it up yet. After you get your letter down, I want you just to kind of hide it, turn it over, so someone else can take your answer. I want to see what you guys think. Cockroaches are afraid of light. Yeah, ABC is fine. ABC is fine. A for scientific hypothesis, B for scientific theory, C for not scientifically testable. Give you guys about 15 seconds. Go ahead and get your choice down. We're going to see who's got the right answer, who doesn't, who's close. Okay, so. Alright, let me go ahead and see your guys' whiteboards. Oh, we got a big range of interesting. Okay, cool. Go ahead and put your guys' whiteboards down. Okay, so let's talk about this real quick. Okay, cockroaches. Who all has cockroaches at their house? You have cockroaches at their house? No one has cockroaches at their house? Okay, do cockroaches have eyes? Are you sure?
No,
Are you sure? They do have antennas, but do they have eyes? Can antennas sense light?
yes, no.
Can it? What is light? What is light made of? Photons, right? You have light waves, light particles. Can those antennas actually pick up light particles?
No.
Who's seen a cockroach's eyes before? Do they? Has anyone actually picked up a cockroach and looked at it?
No.
Most picked up a cockroach and looked at it? So how do you know they have eyes? Because you need eyes to see light, right? So how can we say that, how do we know that cockroaches are actually afraid of the light? When you turn the lights on, they scatter away? No. Not necessarily. Okay, so this is what we're going to do. With cockroaches, can you actually test out to see if a cockroach is afraid of light? Can you test that out?
Yes.
You put them in a shoebox, you turn on the light, you flip the switch, it turns on, and he's scurrying around. Some of them just sit there, they're real brave, and they just look back at you in that corner. You know about that? The brave cockroaches that sit there and look at you. Not all cockroaches are the same. So, okay, cockroaches are afraid of lights. One thing I want you guys to know is whenever it comes to feelings for insects, what's the feeling that's described here in number 4? What's the feeling that's described, or the emotion? Fear. Fear. When it comes to something like fear, happiness, sadness, emotions, anything like that, whenever that has to do with insects or animals, and we can't necessarily talk to them or communicate with them, that means that basically it's not going to be able to be scientifically testable. It's not. The only way that you can test an emotion is by what? By communication, verbal communication. In the world of science, that's what we take as verbal communication. Now, us as human beings, you know, if you look at your friend has, you know, you can tell when your friend's scared, right? They don't have to say anything, they don't have to, I mean, they may scream, they may not scream. But you can tell fear. Whenever you look at someone's face and they get scared, you can tell when they're scared, right? But in the world of science, we don't take observations like that. Just because they look like they're scared, they could have, you know, they could just be, you know, doing a face. You know, they could just be that. Maybe that could be their face for laughing. They just look like they're real scared when they laugh. You know, you never know. So in the world of science, we actually want to get verbal feedback. With human beings, let's say, if someone jumps out, big old cockroach jumps out at Brandon, and Brandon puts on a scared face.
Does it look like I have a scary face?
Does that look like a scared face? Looks like he's laughing, but it could be a scary face. You don't really know if he's scared or if he's laughing at it. Okay? So that means that the only way that I can verify that he got scared of that cockroach or if he's laughing at it is if I ask him. I go, Brandon, did you get scared of that cockroach?
No.
No. So he was just laughing at it, but you never know. Now let's say with the cockroach. If I walk up to the cockroach and say, hey cockroach, are you afraid of lights? What's it going to say? He can't say anything. I'd probably squish him and stomp on him. I won't even talk to him, even if he fits out. But cockroaches, they can't speak to us. We can't communicate with them in any way. Same thing with animals. Even though a dog's wagging his tail, he looks happy, can we actually ask him, hey, are you happy about that bone? You can't really ask him if he's happy about a bone. Dogs play they're smiling like permanently, pretty much. So they just always look like they're smiling. But you never know if he might be angry. I mean, you can tell. You can tell, like us as human beings, we can kind of sense when a dog's growling at you. He's mad or angry or scared or ashamed or happy. We can tell as human beings. But in the world of science, we actually want verbal feedback when we're dealing with emotions and feelings. Make sense? So, let's take a look at number 4 one more time. Cockroaches are afraid of light. What do you think that answer would be? I want you guys to go ahead and put that down on your whiteboards. Is it A, B, or C? Good. Perfect. Perfect, 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 good, good. Perfect, 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 perfect. Close. Perfect, 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 perfect. Perfect. Okay, very good. So the cockroach, you can't test that. Okay, now if can I make a theory about cockroaches saying that they're not afraid, that they are afraid of light? Can I come up with a theory for that? I could come up with a theory for that, but what's it going to take for it to become a theory? Lots and lots of research and data collection. So, I'm talking about years and years of putting a cockroach in a box, using different types of lights, different sorts of lights, different types of cockroaches, different sorts of surroundings. Put them in a shoebox, put them on a wall, see how he reacts. It's going to take lots and lots of research, but it's kind of pointless to do that. Okay, so real quick, I want you guys to take a look at the front. We got numbers 1, 2, 3, 4, 5, 6, 7, 8. Here, we're going to boil some water. I want you guys to come up with 8 pieces of equipment that we're going to use to boil water. What are 8 pieces of equipment that you can think of that we can use to boil water? Go ahead and just name them out. Bunsen burner. You need a Bunsen burner. A beaker. Water. What else? A flask or a beaker. Preferably a beaker. What else? A what? Goggles. Definitely goggles. Gloves. Thermometer. Very good. You need a thermometer. What else? Okay, if I have a Bunsen burner and I'm burning something, am I going to hold a glass like this with a Bunsen burner? No, I'm not going to do it. What am I going to use? Okay, am I going to do this? Am I going to hold this beaker the whole time when this fire is going just like that, just waiting for it to boil? No, what am I going to do? Use a stand. Very good. So we got a stand, we got a ring over here. What's this ring for? I'll show you guys. Okay, so you guys can put a ring, a stand, wire mesh, put this right over here at the top, put the beaker right over here, and you put the Bunsen burner underneath. So that way you're not holding the tongs. You don't want to have to keep the tongs. Plus, depending on how close you hold the tongs or the beaker to the flame, it's going to depend on how fast it boils and how slow it boils. You want to just keep everything kind of on an even par. So you got wire mesh, you got a beaker, you got a stand, you got a ring, you got tongs, you got goggles, you got water, you got a thermometer, you got a Bunsen burner. What else? Got this hooked up, gas is flowing. What do I need? Need the lighter or the striker. So very good. Any other things? You guys got that? You guys got all 8?
Yes, sir.
Okay, cool. So, okay, the next part says, look to the front of the class and label the following pieces of equipment with the corresponding letter on it. Okay, tell me what this is. What is this? This is A. What is the name of this instrument right over here? This is A. This is a flask. Okay, this is a flask. This is letter A. I want you to tell me what letter B is. What is B? Very good. This is an Erlenmeyer flask. This is a different type of flask. You guys can actually spell it up over here. You got Erlenmeyer flask. We spell it like that. Right up down the board. So Erlenmeyer flask. Remember, there's a difference. This is a flask. This is a Erlenmeyer flask. Okay, so A is flask, B is the Erlenmeyer flask. Okay, what is this known as? This is going to be C. What is this known as? Barrette, very good. You can spell it just like that. This is a barrette. B-U-R-E-T-T. Barrette. And finally for D, what is this known as? Graduated cylinder, very good. This is a graduated cylinder. Okay, so on your whiteboards, for the next question, it says, how much water is in this graduated cylinder? I want you guys to tell me what your answer is on your whiteboards. After you get your answer, I don't want you to show it up. I'm going to ask for you guys to show it. So it says, how much water is in this graduated cylinder? Be sure to use your unit of measurement, which is going to be milliliters. I want you guys to tell me how much is in there. And remember, I'm looking for a decimal point. I'm looking to get it as exact as possible. Getting to be as exact as possible. So you guys tell me what you think it is. And feel free to get a decimal point. Okay, close Matt, try one more time. Okay, closest. Tom, very good. On point, Brian. That's what I was looking for. Very good, Brian. Go ahead and erase that. Okay, let's see. On point. Argus, very good. Very close. I mean, that very close. Let's see. Close. 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 Closer. Close. Close. Perfect. Okay, so real quick, quick hint. I want to ask you guys this. Okay, so if I have a graduated cylinder, real quick, take a look here at this graduated cylinder. Where do I measure the water? Do I measure it at the very, very bottom or at the very, very top? At the bottom. What's that known as? The meniscus. This is known as the meniscus. So what you want to do is every single graduated cylinder or beakers, they always have a curve to it because of the polarity of water. So you always measure at the very, very bottom. Depending on if you're in a beaker or if you're on a graduated cylinder, it's going to curve no matter what. Depending on the instrument, it could curve more or less. But wherever that curve is, you always measure at the very, very bottom of that curve. So today, whenever you guys do your lab, you guys are going to be making sure that you're on point with the meniscus. So real quick, what was the answer? What would you guys, so take a look at, looking at that again, what do you guys think the answer would be? 32.9. Very good. I'm looking for a real decimal point. If you guys kind of have to estimate it. We know it's not at 33. We know that's a fact because it's a little bit below 33. So we're going to go to a decimal point, like I kind of asked you guys to do, so it's going to be 32.9. And that's the answer I'm looking for. So today in your guys' lab, when you guys do your measurements, be sure that you always measure at the meniscus. How do you look at a meniscus? How do you look at the meniscus?
Eye level.
Eye level. Very good. So that means that you have to keep it stable on a flat surface. You get down to it and you look at it right at the eye level. Remember, I hate the meniscus. It's very annoying. But the way you look at it is make sure it's on a flat surface, and you're going to make sure that you're looking right at it. Not a little above it or a little below it. You're going to be making sure that you're looking right at it, eye level to it. So for example, if this is where the meniscus is at, your eyeball is going to be right over here. Your eyeball is going to be right over here looking right at it. Like, a little bit lower. It's going to look just like that. So you're going to be eye level with it. Your eyeball is going to be looking just at it. Right at it. Okay, so go ahead and turn the back. Okay, turn to the back page. It says, one of the computer monitors has suddenly burst into flames. What should you do? Spray it with a fire extinguisher? If you unplug the computer, can you unplug a fire?
No, but you have.
What do you guys think the answer is?
Not until you first. I'm like, hey, there's a fire.
The answer is spray it with fire extinguisher. So, very good. So spray it with a fire extinguisher. Remember, fire blankets, that's for humans, not for computers. Dump water on it. It could be electrical fire. Water won't necessarily put that out. It could be a chemical fire. Water won't necessarily put that out. And of course you can't unplug it. You can unplug a computer, but you can't unplug A5. Okay, you squirt yourself in the eye with an unknown chemical. What should you do? Very good. Use the eye wash station. Okay, number 3 says, what piece of personal safety equipment could have prevented the emergency in question 2? Very good. Goggles. Very, very good. Okay, number 4 says, while both acids reacted, H2SO4 was stronger than HCl. On your whiteboards, I want you guys to write down R or C, whether you think it should be in the results section or the conclusion section. On your whiteboard. After you get your answer, just quickly show it to me. I'll tell you. Very good. Close. Try one more time. Good. Good. Close. Close. Good. 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 Close. Good. Good. Close. Good. 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 And good. Okay, so. Very good. So, let's kind of break this down. Okay, while both acids reacted, H2SO4 was stronger than HCl. What makes that a conclusion and not a part, or not part of results? If it was results, it would look something like this. H2SO4 reacted, dot, HCl reacted, period. All it is just results. You're just recording your results. H2SO4 reacted, period, HCl reacted. Now it's a statement, or it's a conclusion, because you come to the conclusion that while both acids reacted, H2SO4 was stronger than HCl. That's a conclusion. Kind of like if you saw a MMA match. 2 guys are fighting. You say, Anderson Silva, he fought last night. Tito Ortiz, he fought last night too. Okay, that's just a fact. That's just a result. They both kind of fought. And then you can say kind of something like, let's say Silva is stronger than Ortiz because he had more hits on him, he basically knocked him out, etc. That's more of a conclusion. That's a conclusion you come to, that so-and-so is stronger than the other guy. It's kind of like with acids. You got H2SO4 was stronger than HCl, but it would be part of the results if H2SO4 reacted and HCl reacted as well. So take a look at number 5. Is that a result or a conclusion? You guys don't have to write this on your whiteboard. I just want you guys to tell me. It's a result. Very good. So all it is just statements, or just facts. H2SO4, CO3, and HCl reacted. FeCl2, and H2O did not. How would you turn number 5 into a conclusion? Go ahead and someone just shut that out for me. How would you change number 5 into a conclusion? How would you reword it to a conclusion? And you can make anything up. You can say something like H2SO4 is weaker than CaCO3, while HCl is stronger than FeCl2 and H2O. It's kind of just a conclusion. Make sense? Okay, real quick, why don't you guys take a look at the bottom, and I'm going to basically act out the story for you guys that are a little bit more visual. Because whenever I was in high school, I always hated reading through these things, and I want you guys to first get an idea of what I'm looking for before you read through it on your own. So, real quick, okay, I want you guys to take a look here at the front. Okay, this is what I do. I'm going to illustrate a little story for you guys that kind of goes along with this question down here. Okay, so, this is what I do for a living. All I do is staple papers for a living. I'm part of a company, a 100-person company, including myself, that staples papers. We're all really bad at our job. Basically, me and 99 other guys, when we staple papers, we staple about two papers a minute. So that means that if you give me a stack of, let's say, 1,000 papers, it's going to take me a long time to staple that. I staple about 2 papers a minute. This is how it goes. Grab my 2 papers, grab my stapler, and I staple it. Put it back on the ground, on the desk. I look around, waste some time, look back at the next stack, pull out the other next 2 papers, and I staple it again. By the time I've stapled 2 papers, 1 minute has passed. But I don't feel bad because everybody is like me. There's about 99 people in my company that are just like me. We're real slow at stapling. Okay, now, some guy comes up to me. His name is Smithers. He comes up to me, and he's got something called a special juice. He's got a special juice. He made this special juice in order for us to drink it so we could possibly staple a lot faster. Alright? So, our boss puts me in group A along with 49 other people. And then the boss splits up the rest of us, which is 50, into group B. Smithers, in group A, he takes the special juice and he gives it to me and the 49 other guys in group A. So we drink that juice, so we drink the juice, it tastes pretty good, and we start stapling, to see if it actually increases our productivity. We're stapling, while the other guys also staple too, but they don't have the juice. Okay, so real quick, before anything happened, what was the new thing that was introduced into this scenario? What was different? What was introduced into this scenario? The special juice. So, I want you guys to keep this in mind. The independent, dependent variable, control, and constant, they're always kind of tricky and confusing. But I want you guys to take a look at the independent variable as the new thing, or the new thing that's kind of put into a scenario. So, for example, you guys told me that the new thing that was added to the scenario was the special juice. That would be your independent variable. Independent variables are always the game changer or something that's new that's introduced into a certain situation. We have a situation here where I'm just a crappy stapler along with 99 other guys, and we have something new, which is the juice, which is introduced into this little scenario. Okay, so independent variable is the juice. And the dependent variable is called a dependent variable for a reason. Why? Because it depends on the independent variable. Okay, what's the dependent variable? If you staple my papers or not. The dependent variable depends on the independent variable. Since the independent variable is the special juice, and the special juice is supposed to do what? Increase stapling, that'd be your dependent variable. So it'd be the amount of staple or papers you staple. That'd be the dependent variable. The amount of papers you staple. Basically productivity. Okay, so after an hour, Smithers counts how many stacks of papers each group has made. Group A, the group that I was in, drinking the juice, actually has less papers stapled than Group B. What could your conclusion be? That the special juice doesn't work. In fact, it makes things worse. You just actually slow down with stapling papers. Okay, so I want to ask you guys this. Number 6 says identify the control. What does control mean? Very good. The control is pretty much the thing that stays the same. Which group stayed the same? Just doing exactly the same thing they do day in, day out. Group B. Group B. Very good. Group B was the one that stayed the same. They didn't get any juice. They kept on going about their day, just as they do every single day. Now, number 9 says identify the constant. What's a constant? What's a constant? It stays the same. Very good. It's something that stays the same. So in this scenario, I want you guys to tell me what's something that stays the same in this scenario. Group B stayed the same, and that's known as our control, so you're correct. What are some of the elements in this scenario that stayed the same? Papers stayed the same. Very good. We didn't use thicker papers. Staplers stayed the same. It's not like we used any special staplers. We all had the same staplers. What else? What's a constant? What are some of the same things that just stayed the same in the scenario? The people did. The workers stayed the same. It's only that the juice came and maybe affected the other guys, but workers were the same. We didn't give them any certain, special papers. What else? Time. Time's a good constant. Time will always be a constant. Because, for example, I'd staple papers within 1 minute. I can't actually stretch out a minute. Whenever I count to minute, it's always 1, 2, 3, 4. I can't make a minute stretch out like 1, 2, 3. I can't stretch out a minute, so time is always going to be a constant. So always look for that. On the tax test, whenever they ask you guys, what's a constant, always look for the, the group of words that has the word time in it. Time will always be a constant. You can't control time. It's always going. Okay, cool. Alright, so everyone should have 100% on this. Be sure you have your names at the top. As you guys are passing these forward, I want you guys to go ahead and pull out your assignment from last class with the little pH tags. So go ahead and pull that out, and I want to go over what you guys got. I want you guys to dip your pH these into it. So go ahead and pass it to the front. I want you guys to go ahead and put up your whiteboards, put up your markers. Go ahead and put up your whiteboards, markers. I want you guys to pull out what you guys got. Okay, so real quick, how many of you guys, what was the most interesting solution you guys dipped your pH tab into? Anyone have any real interesting solutions they might have dipped their pH tab into?
Water.
Water. When you dip yours in water, what happened?
It just like, well, it turned into the color and then like where you stopped dipping it at, it changed colors like to a brown.
To a brownish color?
Yeah.
Okay, cool. What are some other results someone got from the solution? Brandon?
I did mine in soda, some sun-kissed soda.
What color did it change?
Orange.
Orange?
And
Cool.
when I put it in there, it started like bubbling a little bit.
It started bubbling a little bit? Cool, cool. You didn't drink it afterwards, did you? Alright, good. Remember guys, don't drink drinks whenever you stick pH tabs in them. Okay, anybody else? Anybody else? Anything interesting they dipped it in? Anyone dip it in milk? Vinegar? Anything like that? Okay, cool. So, with y'all's papers, be sure that you guys go ahead. If you guys have the pH strips, I want you guys to keep the pH strips to yourself, unless you tape it to your, if you guys tape it to your paper, that's cool. If not, I want you just to go ahead and keep it to yourself, the pH strips, and just kind of keep that as a reference, because I will be showing you guys something here pretty soon. Yeah, so go ahead and pass that to the front. Go ahead and pass your things to the front. So go ahead and pass your papers to the front. I'm going to come by and pick them up. And hopefully